The coordinates of the vertices of a triangle ABC are given to us. We need to find out the equation of the altitudes of the triangle and the coordinates of its orthocenter. So let us begin by first constructing a triangle with its altitudes. So here we have a triangle ABC. Coordinates of A are 10, 4, coordinates of B are -4, 9, and coordinates of C are -2, -1. So here AD, BE and CF are altitudes of the triangle, meaning AD is perpendicular to the side BC, BA is perpendicular to the side CA, and CF is perpendicular to the side AB of the triangle ABC. Our goal will be to determine the equation of AD, BE and CF, and also we need to find out the coordinates of the orthocenter. That's the point which is the intersection of the three altitudes of the triangle. That is going to be the orthocenter of the triangle. So we'll need to find its coordinates. But first we will try to find out the equation of the altitudes. Now what we'll do here, let's quickly go through the formula that we will be using in order to find out the equation of any given line. So here what we will be using is known as the point slope form of a line. The point slope form of a line states that if we know the point through which a particular line passes, let's say the point B having the coordinates x1, y1, and we also know the slope of that line, then the equation of the line will be given by y minus y1 equals to the slope m times x minus x1. Fine. So here that means in order to find out the equation of the altitudes, we need to find out the required slope. So we're going to specify the slope of AD as m1, BE as m2, and CF as m3. We'll begin by first obtaining the slope of the altitude AD. Here we're going to use a property of straight lines. Since AD is perpendicular to BC, let's write it down. Since AD, this is the altitude of the triangle, is perpendicular on the side BC of the triangle, this implies that if we take the slope of AD and multiply it with the slope of BC, then the product is always going to be equals to -1. So that's a property of straight lines. So here the slope of AD, which we have defined as m1 times slope of BC. Now we have to find out the slope of BC. That's very simple because we know the coordinates of point B and point C. All we have to do is take the ratio. In the numerator we need the difference of the y coordinate. So we'll do 9 minus -1, 9 minus -1, and in the denominator we'll take the difference of the x coordinate. So we'll do -4 minus -2. So this will be equals to -1. So let's compute. So we have m1 multiplied to, so 9 minus -1, that's going to be +10, divided by, so here we have -4 minus of -2, that means we're -4 plus 2, which gives us -2 in the denominator. This will be equals to -1. So solving for m1, this will be equals to +1 over 5. So that means the slope of the altitude AD, that's going to be 1 over 5. Now the altitude AD passes through the point A and has got a slope of 1 over 5. So this implies that the equation of our altitude AD, we can use the point slope form to get y minus y1. So here y1 will correspond to the y coordinate of point A, so that's 4. That will be equals to the slope of line AD, altitude AD, times x minus x1. So x1 will be the x coordinate of point A, so that's 10. Let's multiply it throughout by 5. So we have 5y minus 20 equals to x minus 10. Rearranging the terms, we get x. We're going to transpose 5y to the right hand side. So we get x minus 5y, and combining positive 20 and 10, we get positive 10. So this will be equals to 0. So that means the equation of the altitude AD, so that's going to be x minus 5y plus 10 equals to 0. So using the similar technique, we will be able to obtain the equation of line BE as well as CF. So let's do that. Now we want to find out the altitude of BE. So here by definition, slope of the side AC times slope of BE, the product will be equals to -1 since they are perpendicular to each other. So slope of AC, that's going to be, so we'll start with the difference of the y coordinates. So we have 4 minus -1, and in the denominator, since we started out with point A, so now we will do the difference of the x coordinate will be 10 minus -2. Multiply to slope of BE, so we consider it to be m2, that's equals to -1. So we have 5 divided by 12 times m2 equals to -1. So slope m2 comes out to be equals to negative 12 over 5. Now we have the point B to which the line passes. So we have negative 4, 9. That's the coordinates of point B. So using these point slope form, our equation of the line or the altitude BE is going to be y minus 9. So that equals to the slope, which is negative 12 over 5 multiplied to x minus x1. So x1 will correspond to negative 4. So we have positive 4 here. So we get 5y minus 45 equals to negative 12x minus 48. So we get 12x plus 5y equals to, so 45 minus 48, that's negative 3. So this is going to be the equation of the altitude BE. Similarly, we can find out the equation of the third altitude, which is CF, that I am leaving as an exercise for you to try out. So the equation comes out to be 14x minus 5y plus 23 equals to 0. So now we have the equation of all the three altitudes. Our next goal will be to find out the coordinate of the orthocenter O. Now, in order to find out the coordinate of point O, all we have to do is take any two altitudes and solve those two equations. That's going to give us the coordinate of point O. So let's start with AD and BE. So here what we'll do, we'll add the equation of AD with that of the equation of BE. So that means we have x minus 5y plus 10 equals to 0. And to it, we are going to add 12x plus 5y plus 3 equals to 0. So let's do the addition here. So 12x added to x, that will be 13x. So positive 5y, negative 5y cancels out. This will be added to 10 plus 3, that's 13 equals to 0. So solving for x, we get the value x equals to negative 1. So we can replace x equals to negative 1 in any of the three equations to obtain the corresponding value of y. So let's start with the equation for AD. We have x minus 5y plus 10 equals to 0. We're going to replace the value of x with negative 1. So we have negative 1 minus 5y plus 10 equals to 0, which gives us the value 5y equals to 9, or y will be simply equals to 9 over 5. So that means coordinate of the orthocenter, so we have the x coordinate as negative 1 and the y coordinate is 9 over 5. That's the final result.